Hi, this section is all about using the right graph for your data. So let's get started. In this section, we are mainly going to take a look at which graph we should use at which particular place. Our basic goal is to understand that amongst numerous number of graphs available, which graph can we use where, so that you're not confused. After that, we will move on towards the visualizations that we would do in R, then Python, and finally, we will kickstart with our visualizations in Tableau. So let us begin with our demonstrations using R. In this video, we are mainly going to take a look at first understanding which graphs to use where, then creating some basic graphs in R, and finally, and the most important skill that would be expected from any good data visualization expert is to draw inferences from those graphs. Our main goal should be that whatever graphs that we make, we are able to derive some reasonable inferences out of them so that the entire process makes sense. And finally, once we are done with that, we will try to create a simple data analysis report, a data visualization report, which would not just help us present to our audience, but also help us interact with them. So, which graph should we use where? This may sound a bit theoretical for now, but just hang on. This is really important. This is the foundations of good visualization practices. The moment you remember this, you will do really good. So let's get started. So it's really simple to decide which graph to use depending on the data that you have. So first we learned from the previous video is that there are three kinds of data types. You have numeric, you have factor, and you have string variable. Now, for numeric data, you could use a box plot or a histogram. Why? Because numeric data basically consists of numbers which could be added, subtracted, or you can find an average. So it is quite obvious that you would try to understand the minimum, maximum, average, median, and this would help you understand in case you have any outliers in your numeric data. It's also really good to see a histogram because that helps you understand the symmetry of your data or where is your data more skewed towards. For example, if we take age in numeric data, then with regards to a histogram, the number of data points that you have could have either age below 20, so your histogram would be skewed towards the left, and if you had your age somewhere above 40, then your histogram would be skewed towards the right, which is a good idea. It really helps you to understand things quickly. But what about factor data? Well, for factor data, you could use a bar chart. As simple as that. Think of it like this. Say you have factor data of gender. You have male and female. Now you want to see that in your data set, which number of gender is more in your data set. So simply you could plot a bar chart where the first bar indicates the number of males in your data set and the second bar indicates the number of females in your data set. Just visually looking at them, you could understand that which gender is more in your data set. But now let's try to understand what would happen when we combine two data points or two columns. So say both your columns are numeric variables. Then you can use a scatterplot to find the relationships between them. Take an example here. Say the first variable is wealth, which is on the y-axis, and the second variable is age, which is on the x-axis. It is normal to understand that as a person's age increases, so does his wealth. So, it would show a relationship in a linear fashion. It's not always true, but just take this one as an example. It really helps you to find relationships quickly, and scatter plots are really useful. Now take a numeric and a factor variable. Well, in this case, we could use a bar chart, stacked bar chart, box plot, or tree map. For two factor variables like say gender and probably whether the person has a PC or not, we could use a stacked bar or a mosaic plot. For a string variable, if needed, we can use a word cloud. So remember, we have three data types: numeric, factor, and string. For numeric, we could use a box plot histogram. For a factor, we could use a bar chart. For a string variable, we could use a word cloud. When we combine more than one variable, for numeric variables, we can use scatterplot. For numeric and factor, we could use a bar chart. And for two factor variables, we could use a stacked bar chart. This is really important, and we'll see this later. So let's actually begin plotting things in R. So in this section, we are going to mainly be taking a look at the diabetes dataset, PIMA Indian diabetes dataset. Now if you remember, the PIMA Indian diabetes dataset consists of some really good data points which explain to us whether a person is pregnant, whether a person has diabetes or not, and all the columns that we have are currently numeric values. However, some of them are factor variables also. So the first practice that we begin in R is by loading the check install load function. What this function mainly does is that it checks whether the packages that we need exist on this PC or not. In case the package doesn't exist, it installs the packages, and once the package is installed, it loads it. So there is no need to manually go in packages, click on install, or probably run the command install the packages manually. You simply just need to load the script once. Then we go to the data.r script. The data.r script is just reading the CSV file diabetes.csv from my root variable. And then we finally go to eda.r. In eda.r, I'm finally running libraries.r, thus loading all my libraries, and then data.r so that all my data files are loaded. So let's begin running some of them. So let's first load libraries.r. Okay, so all my packages are loaded, and now let us load my data. Great. So it seems like I have 768 observation of 9 variables. Now, let's take an example. So, we know that in our data, we have the column age. So, age is a numeric variable. So, let's try to create a histogram of age. That's amazing. So, R has created a plot for us. Which looks quite good. And if you see the distribution of the age which is currently there in the PIMA Indian diabetes dataset, is that the most number of people have an age that of below 30 years, because most of our people in the dataset are around 20 years, probably a bit more than 250. So an histogram acts really helpful. Let's take a look at a normal bar chart. So the pregnancies is a factor variable that we have of a user. So a person can either be pregnant limited number of times. This makes it a factor. So if you see this line here, we have specified pregnancies as a factor variable that we are converting as a table and plotting in a bar plot. So our users are mostly not pregnant or pregnant once or pregnant twice or pregnant thrice, and these consist of most of the data points in our data set. We are already making so much progress, right?